Okay, guys. What I remember is we did, uh, I think we did orbital angular momentum and spin angular momentum. Orbital and spin angular momentum. In the class. Here I just summarize, I just discuss an overview of this orbital and angular momentum quantum number. Like in Bohr theory, we know that the angular momentum, which I represent by P of phi, is an integral multiple of h bar, where n is the principal quantum number. While in Sommerfeld theory, the angular momentum, which is P of phi, is also an integral multiple of n of phi times h bar, where n of phi is called the azimuthal quantum number. Quantum number. Now, in vector model, n of phi is replaced by L. We replace n of phi by L, where L is the orbital quantum number. So if we replace L by n of phi by L, then this angular momentum, which is P of phi, is equal to L h bar. Now this is the classical expression. Classical expression of angular momentum. Now, it was found that now here I replace this angular momentum by L, where L is the orbital angular momentum. Angular momentum. I replace it by L, and this L is equal to this L. So I will take the magnitude of this L, which is this one or just L, is equal to L into L plus 1 in square root into h bar. Now this equation 4 gives us the wave mechanical angular momentum. It's the wave mechanical expression of angular momentum. We already did these things in the class in a detailed way, so I'm not going to explain it again here. So here in this equation, P of phi, which is equal to L into h bar, we replace P of phi by L, and this L by L into L plus 1 h bar into h. So we replace L by L into L plus 1 square root. Now this L into L plus 1 has positive values. Started from 0, 1, 2 and so on. Like up to n minus 1, yes. Now, when L is equal to 0, like if the principal quantum number n is equal to 0, then we have L is equal to n is equal to 1. Sorry, n is not equal to 0. N is equal to 1. The lowest value of n is 1. Then L is equal to 0. This represents the S subshell. For n is equal to 2, we have L is equal to 0, 1. So this represents S and P subshell. For n is equal to 3, we have L is equal to 0, 1 and 2. So this represents S, P, D subshell. So this 0 represents S, this 1 represents P, and this 2 represents D, and so on. Now the magnitude of angular momentum, which we wrote it like this, L.